Okay, I think it is starting to record. We'll find out at the end of class. All right, so this one is the hyperbola, and so we're going to go over some new definitions. Actually, they're kind of the same definitions, which will be cool. I have on the board the definitions from the last time we were doing with the ellipses. The A is still going to be defined as the distance from the center to the vertex. So if I were looking at this one right here, I could find the center would be somewhere about there. And we're going to give the center is still going to be variables hk and all of our equations. The distance from the center to the vertex, I'm going to put an X on the vertex, and there's two of them. The distance from the center to the vertex is still going to be A. The other thing that you should notice is a new term is transverse axis. And transverse axis is the axis that goes from a vertex to a vertex. Now on the paper here I'm showing a transverse axis. In both of these I'm showing a transverse axis that's horizontal. On the board I've drawn one where I have the transverse axis is vertical, which means I still have a center right here, but now my vertexes are up and down from each other. All right, and then they will do this in some regard. And notice the focus, the two foci are always inside the parabola looking thing. All right? What's that?
Why is it?
That's just because it's the focus is kind of it's how it's kind of going around. That's the thing that kind of makes these all of these conics. The definition, you remember we had definition for a circle was I start in the center and I have a fixed length and I just all the points that are that distance away from it. With an ellipse, we had the center, but then we like put two foci on either side of the center, so the center is still in the middle of the foci, and we had a piece of string. You remember I drew it on the board. We had a piece of string that stayed the same length, and so when I moved the string around, I was measuring how far it was from the focus to that point, plus from the other focus to that point. It stayed the same all the way around. With this, you take focus to a point, focus to that point, and when you subtract those values, you get the same thing all the time. So their difference stays the same. This was very, very difficult to draw as far as a construction. I did a YouTube search to try to find some way to do it. If you're interested in that, you can do a search on constructing a hyperbola. It involves using a ruler, some string, a rubber band, and it's fairly complicated, but you can actually do it. It's not the easiest thing to do. It took me a while to kind of figure out what they were talking about when I was listening to it. But so I'm not going to demonstrate how to do it. That's not as important at this stage right now as just being able to get the definitions and apply them. All right, so A is the value from here to the vertex, which is the same definition we have. From the center to the vertex is A. From the center to the focus is C. So notice this time C is going to be bigger than A. all the time. It has to be, because it's on the other side. You have to pass through the vertex to get to the focus. And in fact, they're going to be related. C squared will equal A squared plus B squared. Okay, nowhere on here do I show a B anywhere. Now you remember B with the ellipse was the shorter one. It's not always going to be the shorter one now. It may actually be longer than A. It's just going to have the name of the conjugate axis. And it will be in the other direction. So the conjugate axis will be what it's on. And there's some point in space, and the distance from the center to the endpoint of the conjugate axis is your B value. So it's kind of like when we were drawing the ellipse. We went out to the vertices, we went up and down to the co-vertices. Now we're just going to some point in space that's the endpoint of the conjugate axis. All right, the reason why these are important to find is because you then take this and you draw a box. So you use your A values and your B values to draw a box. You now take and draw diagonals through that box. So you got to hit the center and you've got to hit the corners. I don't think I drew a very good box there. Okay, and those diagonals that we drew are asymptotes, which is what the parabola-looking parts of the hyperbola follow. Okay, so if I drew this one, and I'm going to just freehand this. Okay, so the hyperbola will asymptote with those diagonals. Okay, and some places you'll see them called branches of the hyperbola instead of me saying parabola-looking things. Okay, probably a little more technically correct. All right, look on this. So that's in general, that's how they look and all the definitions. So your two new definitions are transverse axis and conjugate axis. So let's look at the standard equation for a hyperbola. Notice there's two different ones right there. What do you notice that's different from an ellipse? Yeah, the A value stays stationary. What changes here is sometimes, notice Y is still teamed up with K, the Y value of your center, and H is still teamed up with X. But that whole term flip-flops, but A always stays right in the front. What else do you notice that's different? They're subtracted from each other instead of adding to each other, okay? So that's the only thing different, except we have those new terms and everything, and we have c squared equals a squared plus b squared. So now the next question should be, how do I know if the two branches are up and down, or are they left and right? And the thing is if A, the very first term, is under the x's, then your transverse axis is stretching in the x direction, which means that they're a left and right branch. If your transverse axis is up and down, then you have an up and down branch, parabola-looking things. Okay? So that's the general stuff. Get your worksheet out and we'll do a couple examples. Make sure you guys have this. Okay, so let's start with number 1. And if you're going to sketch these, you're going to first find the center. So where would the center of this hyperbola be? -1, comma 0. Don't forget, you still do the same thing where you switch the sign. Okay? Big mistake a lot of people make is they're used to having x, y, and they write it backwards. So
1 and 0?
Yeah, so it's the -1 since you have to switch that. So -1, 0 is the center. So let's put an x on -1, 0, and that's our center. So everything we do will radiate from there. All right, your a value comes from here. That's a squared. So what would a be? 5. It's under the y, which means it goes up and down, like the y-axis does. So go up 5, and that's going to be a vertex, and go down, and that's going to be a vertex. Put a little V there if you want to remember. Okay, so the b value, this is b squared, so the b value would be 3, and that would be a left and right. And this allows us to draw our box. If you want to get a ruler because you want to make sure they're all nice and neat little lines, then go for it. They're in the top drawer back there. And after you get your box, make your diagonals. Okay, so I've made my asymptote, so all of this that I've drawn in black is just how you set it up before you actually draw the actual equation. So I'll draw the actual equation graph in red. I find where my vertices were. If you didn't label it and you forget, you can just go back here and it's under the Y. The very first one's always where you're going to find your vertices, so that means it's an up and down one. So you come here and make it go out and kind of hug your asymptotes there. So from the vertex, and that's a good representation of what you would get if you were to graph this. Okay? All right, let's look in 5 and 6 now, where we're given some information and now we want to make the equation from the information we're given. So the first thing you should notice is that your transverse axis is vertical. You should be able to pick up the center pretty good since they give you the diagonals crossing there. So transverse axis being vertical means that's a Y dominated. So the Y is going to come first. All right, the center is at -1, 2. So make sure you put the 2 with the Y, so that would become a -2, and the -1 with the X, that becomes a +1. And now we count. 1, 2, 3. So A is 3. So I put 9 right there, squared. 3 squared. And 1, 2. The B value is 2. So I would put a 4 right there. Okay.
How can you determine your
I drew the box.
Okay.
Yeah, these are kind of sketched in for you. If you have trouble, use the asymptotes to kind of see where, as you go across.
I can see the box.
It's hard to see the box on these lines, so just use you can see where the vertex is, and if you just go over until you hit the asymptote, that has to be the corner of the box. So then you can just drop down from there. Yeah. Yeah, it's very faint. If I turn the lights on, we could see it a little bit better. You can see it on mine projected up here a little bit better. So I'll go ahead and sketch that out for the next one. So we
On
can.
the test where we have the box.
I'll make the box a little darker. Okay, so here the center is at 3, 0. It's a vertical transverse axis, which means the Y values go first.
So are we going to have to state if it's vertical or horizontal?
Well, you have to know that to know which comes first.
Oh, yeah.
Yeah, so that's probably all you need to know. Okay, and then under the Y will be the A, and A is how far up to the vertex. So 1, 2, 3, 4, and you take 4 and you square it. So 16 would go here, and that's 2 over 2 squared is 4, and there you have it. Okay, easy enough? All right, let's flip to the back, and let's look at how we'll go about completing the square on one of these. Notice you have an x squared that has a negative in front of it, and we want that minus to end up going second. So we're going to start with the y's because they're not negative. So start with the non-negative terms to complete the square with first. So this was nice. The y didn't have any coefficient in front of it. The y squared didn't. So that'll be an easy complete the square one. 4. All right, the x's, I'm going to want to factor out a -4. So what happens with the negative 32x when I factor out a negative 4? What do I get?
You get an 8.
A positive 8, right? Yeah. So that, a lot of people mess up because they'll forget I factored out that negative already, so it switches back to a positive. So if it had been a positive and I factored out a negative, then I switch it back to a negative. Okay, so that negative 256 wasn't working for us, so I added it to both sides. I just randomly put a blank there, so if I add it to one side, I have to add the blank to the other side. Now this blank here that I added gets multiplied by negative 4, so I'm going to put minus 4 times blank. Okay, half of negative 4 is negative 2. Negative 2 squared is 4. And put it in the blank on the other side.
So do we have a 4, correct?
What's that?
A 4.
Yes.
So it's just something, whatever, it's just squared.
Half of 8 is 4. 4 squared is 16. So the 16 goes in that blank. And now you just do 256 plus 4 minus 4 times 16. And since this is the 4th class I've taught this with, I have that memorized. It's 196. I am not that smart that I can actually do that in my head. That wouldn't be too hard. Yeah, that actually, well, yeah. It's the end of the day. We'll just leave it at that. Okay, now you come back and the same thing you did with the ellipses. You divide it out. So this now becomes 1. This right here reduces down to 49 on the bottom. And this one we don't have to reduce down. And I should have left more room, shouldn't I? Sorry about that. Okay, so that's how you do the complete the square with this. The only tricky part with this, different from the ellipses, is you're pulling out a negative here, and you have to take care of what you do when you have a negative. All right, let's do number 9 to show another way with some different information of how we would do this. All right, vertices. Your center is in the middle of your vertices, so let's find the average x value.
Indecisive.
Mm-hmm.
So what I've been doing, because like I didn't really understand the average in the test, and when you gave me the 2 vertices, I numbered it all from 19 all the way to -9, which came across the like all the way.
You can do that, yeah. You can actually lay them out on. If you didn't understand what he said, he like put it out on like a number line, and then just kind of walked his way into it. Takes a long time. It's easier if you just add it together and divide by 2. All right. Yeah, so 19 plus a negative 9 is 10. 10 divided by 2 is 5. All right, 3 and 3, I think we can just do that without even having to add them up. That would be 3. So there's your center. I like to write here, since I want to start writing it out. I'm going to just sketch out what's going on here. I know that I start at 5, 3 for the center. The vertices, are they changing from the center by going left and right or up and down? What changed? The x values, right? So that's left and right. So I have over here's a vertex, over here's a vertex, which means I have one that's doing this. And there's my conjugate axis. Not conjugate, that's my transverse axis. So that tells me X is going to lead off. All right, so that's why I sketch it, just so I have it there when I start writing everything in, I know what I'm doing. All right, so I'm going to start with my X's. So -5. All right, now I have to find the A value and the B value. Well, the A value is centered to one of these vertexes. So from 5 to 19, how far did I go? 14. 14 squared. That's 196, the number we had up there. All right, and it says that the conjugate axis is 8 units long, so that's overall. So half of that would be 4, and squared is then 16.
What's the conjugate axis?
Conjugate axis is just where the B's are on the edges of. It's when we drew our box is how far out we went. So it's just some point in space. It really doesn't have any real meaning except helps you draw it. Usually if you're going to use this to model maybe something in physics with a comet coming into the solar system, you're going to know how far it gets to the focus, so you're going to know a C value, and you'll probably also know an A value from the to the vertex from whatever the center is. Okay, so the B value is just there somewhere. Who knows? All right. So what I want you to do is complete this. All right. So now we're going to classify the conics. And this is a picture I copied out of the book. It's not nearly as cool as the book, which has it in color. So if you want to see it in color, it looks really cool with that. It's, of course, nowhere near as cool as my samurai sword thing of chopping it. But anyway, you can see them being chopped as pieces of different ways you would chop a cone that's, for some reason, touching another cone up, inverted above it. I don't know why that would happen. But anyway, all right, so if we're going to classify these, all of our equations is not going to have that xy term. So you're just looking at the x squared term and the y squared term. The rest of the stuff is noise. Ignore it. If you have the a and the c, in other words, the coefficient in front of x squared and y squared are exactly the same, +1 and +1, you have a circle. If you look at that, and if you multiply them together, you got 0, meaning one of them was 0, but not both. In other words, you only have one of them there. You only have an x squared or a y squared term. The other one is not there. You automatically have a parabola. Okay, that's the easiest one to pick out. If I had a list of 10, I would go through and I would find all the ones that only had one square term, and I would know those are parabolas. All right, if A times C is greater than 0, meaning A and C have the same sign. Usually they're both positive, but they could both be negative. Okay, you would still have an ellipse. All right, so ellipses, A times C is greater than 0. Hyperbola, one of them is negative and one is positive. So that's all we're looking for as we go through here. All right. The first 10 I have on this sheet are going to be in their standard form. So this is what we would write the equation out if you gave me the information. If you gave me some information about the center, the radius, or foci, or any of that sort of thing, and you told me it's an ellipse or whatever, then you could write these out. So, number 1, does that look familiar to you guys? I've got 2 things squared, so it's not one of the parabolas. I'm not dividing anything, so what is this one? You can do hand motions if you want. Yeah, it's a circle. Very good. All right, so we had, so we have H is 0, K is 1, and the radius is the square root of 21. All right, if I squared it out with the definitions I had, I would have an x squared and a y squared. So they're both have a coefficient of 1. They're both positive. Circle. All right. Number 2. That's also a circle. Number 3. Also a circle. Number 4. That is an ellipse, all right? I've got equal to 1s divided by numbers, and I've got a plus in between here, ellipse. Number 5. Parabola. That's only got one thing squared. Number 6. Ellipse. Number 7. Ellipse. Did I tell you this was easy once you get the hang of it? Number 8. There you go, the H. Number 9. That's a hyperbola again. Yep, that minus there. And number 10 would be a parabola. Okay?
Are they all that easy?
Yeah, I think they get even easier.
Oh.
You gotta work it out next.
All right, now all you have to do is right here, all of this is noise. Don't care.
Oh, so it has a squared.
So you just look at the first 2?
You just look at the square terms. I have a negative and a positive, which means it is hyperbola. Number 12, I only have one thing squared. Parabola. Number 13, I have 2 things squared, but it's a 9 and a 4, so it's an ellipse.
So we would make a circle.
A circle would be a 9 and a 9.
Oh.
Okay? Or a 1 and a 1.
Oh, so number 16.
Alright, 14 is another ellipse. What is 15? Only one thing squared, so that's a parabola. 16
Circle.
is my first circle. And then I get another one here at 17. 18 is an ellipse. 19 is a parabola.
Fun.
And 20 is also a parabola.
Yes. Can we, I'm gonna actually pass this.